In this video, we will discuss questions related to 4 operations involving fractions and mixed numbers, where you have to give your answer as a fraction. So let's consider the first question. The first question involves addition of 2 mixed numbers. So before I start on these questions, I need to understand what this mixed number means. This mixed number means I've got 1 whole and 4 portions out of 12. This mixed number means I've got 3 wholes and 5 portions out of 15. When you have to add 2 mixed numbers, what you got to do is, first of all, you'll ask yourself, can the fraction part of a mixed number be simplified? If it can be simplified, please do so. In this case, 4 and 12 are both in the same timetable, so I'll simplify them first before I move on. So I will divide the numerator by 4 and that will give me 1. If I divide the denominator by 4, that gives me 3. If I look at the second mixed number, I can see the fraction part is divisible by 5. I divide the numerator by 5, that gives me 1. I will divide the denominator by 5 and that gives me 3. So I'm now left with 1 whole, 1 over 3, add 3 wholes, 1 over 3. Now I'm going to change this mixed number into an improper fraction. To change mixed number into improper fraction, we use approach, which is, I can say A wholes B portions over C is my mixed number, and I need to convert this into an improper fraction. So to convert this into an improper fraction, what we do is we multiply A with C and then we add B to it, and our denominator remains the same. So I'll follow this approach and I'll convert these mixed numbers into improper fractions. So I'll write down 1 times 3 add 1 over 3, add 3 times 3, add 1 over 3. Now I can simplify the numerator. This will change to 4 over 3, add 10 over 3. I now have to add the 2 fractions. I see my 2 fractions have a common denominator, so I can straight away go ahead and add them. Remember, when you add fractions, you only add the numerator. So if you add 10 and 4, you'll end up with 14 over 3, and that is my answer. On question number 2, I will follow the same approach, but if I look at it carefully, I see instead of a mixed number here, I've been given a fraction. If you are given a fraction and a mixed number, you don't have to worry. You just have to follow the method. I will check, can the fraction part of a mixed number be simplified? In this case, it can't be simplified, so I'll change this mixed number into an improper fraction. For that, I will follow the same approach, which is A whole B over C equals something like that. I will multiply 2 times 9, add 2 over 9, add 5 over 6. Once I've done this, I can change the numerator, and if I simplify it, it will change to 20 over 9, add 5 over 6. The next bit that I have to do is I have to add 2 fractions. Now I can't add these 2 fractions because they don't have a common denominator. So first of all, I'll have to find a common denominator. To find a common denominator, we always find the lowest common multiple, which is LCM of the denominators. So for LCM, I will write 9 and 6 here. And I can see they both are divisible by 3, so I'll divide them both by 3. It gives me 3 and 2. Now they can't be divided any further, so I'll multiply them 3 together, and that will be my LCM, which is 3 times 3 times 2, which is 18. So my common denominator will be 18. So I'll change this 9 into 18, and the second 6 denominator will also change into 18. Now, what did I do to this 9 to change it to 18? I basically multiplied it by 2. I'll do the same thing to the numerator. Here, I multiplied 6 with 3 to change it to 18. I'll do the same thing to my numerator. Now, if you multiply 20 with 2, you'll end up with 40. If you multiply 5 with 3, you'll end up with 50. Now, this is the same question, just like this one. I've got the common denominator. I'll go ahead and add the 2 numerators. So if you add 40 and 15, that gives you 55 over 80. Do ask yourself, can this be simplified? In this case, it can't be simplified, so therefore it will be my answer. If you're not sure about how to add fractions, I do recommend that you watch my video on 4 operations involving fractions. I've included the link in the description. If you want to access that file, please go ahead and do it from the link given in the description. Let's consider question number 3. On question number 3, I've been given a mixed number and a fraction, and I've been asked to subtract them. Now, the first thing that I'll check is, can the fraction part of the mixed number be simplified? In this case, it cannot be simplified. The fraction itself here cannot be simplified. I will go ahead and convert this mixed number into improper fraction. We'll follow the same approach. We'll multiply 3 times 9, add 2, the denominator remains the same, which is 9, take away 7 over 3. Now the top section, which is the numerator of this fraction, can be simplified, and if you simplify it, you will end up with 29 over 9, take away 7 over 3. Now I see I've got two fractions to subtract, and when you have two fractions, they can only be added or subtracted once they have a common denominator. So in this case, I see I do not have a common denominator. So what I will do in this case is I'll have to find a common denominator that is my lowest common multiple. For that, I can follow the same method like we did on question number 2. I'll write down 9 and 3. Now 9 and 3, they both divide by 3. So I'll divide them both by 3. That gives me 3 and 1. Now I see these two numbers can't be divided. So my LCM, or common denominator, will be 3 times 3 times 1. And that gives me answer as 9. Now I need to figure out the numerator for this stage. So here I multiplied it by 1. I'll do the same to the numerator, because 9 times 1 gives me 9 as denominator. If I multiply 29 times 1, that will give me 29. I have to do the same thing for the second fraction. Here I will multiply this 3 with 3, because 3 times 3 will give me 9. And I'll do the same thing to my numerator. If I multiply 7 with 3, I'll end up with 21. Now what I see is I've got a common denominator and I've got two fractions. So I'll go ahead and subtract the numerators only. So if I do 29 take away 21, that leaves me with 8, and the denominator remains unchanged. So that will be 9. And this is my answer. Let's consider question number 4. On question number 4, I see I've been given two mixed numbers. So the first thing I'm going to ask myself is, can the fraction part of the mixed number be simplified? For both these numbers, the fraction part can't be simplified. So I'll go ahead and change this mixed number into an improper fraction. I will follow the same approach, and I'll do 2 times 9, add 2 over 9, take away 1 times 3, add 1 over 3. If you simplify the numerators of these two fractions, you'll end up with 20 over 9, take away 4 over 3. Now the situation is exactly the same as it was in the previous question. Here I had a denominator of 9 and a denominator of 3, and I had to find a common denominator. Here also I have a denominator of 9 and a denominator of 3, so I'll follow the same method to find the common denominator, and for that I'll write down 9 and 3. I see they are both divisible by 3. I'll divide them both by 3. This gives me 3 and 1. Now 3 and 1 can't be divided by any common number other than 1, so I'll stop and I'll write down my LCM, which is my common denominator, as 3 times 3 times 1, which gives me answer as 9. I can write down 9 here, take away 9. So my common denominator is 9. What did I do to the first fraction? Denominator was multiplied by 1. I'll do the same thing to the numerator. 9 times 1 will give me 9. If I do 20 times 1, that gives me 20. I'll now look at the second fraction. Denominator was 3. It has been changed to 9. How did it got changed to 9? Because I multiplied this 3 by 3. I'll do the same thing to my numerator, and that leaves me with 12. Now I see my two fractions have a common denominator. So I'll go ahead and subtract the numerators, and that leaves me with 20 take away 12 will be equal to 8. Denominator remains the same, and that is my answer. Let us consider example involving multiplication. So again, this time I've been given a mixed number and I've been given a fraction, and I've been asked to multiply them. I'll follow the same procedure with the mixed number. I'll ask myself, can the fraction part be simplified? In this case, I can see it can be simplified. So 4 times 1 and 4 times 3. I can't simplify the fraction part any further, I'll now go on to my second fraction and I'm going to ask the same question. Can this be simplified? Again, I see it can be simplified 3 times 3 and 3 times 4. I can't simplify it any further, so I'll stop. I will now change this mixed number into improper fraction, and for that we will follow the same approach, which is 3 times 3 add 1 over 3 times 3 quarters. Now this will change to 10 over 3 times 3 quarter. At this stage, we'll follow the method that we used for multiplying fractions. So what I will do is, I know this fraction can't be simplified, this fraction can't be simplified. So I'm going to ask myself a question. Can the numbers in diagonal be simplified? And if they can, then I must do that. In this case, I can see this is 3 times 1 and this is 3 times 1. Here, 2 times 2 and 2 times 5. All I have to do now is I'll multiply the numerators and I'll multiply the denominators. And that leaves me with 5 over 2 as my answer. Let's consider another example. But this time, what we have here is we've been given two mixed numbers to simplify, two mixed numbers to multiply. So I'm going to follow the same method. I'm going to ask myself, can the fraction part of mixed numbers be simplified? In this case, I can see it can be simplified 4 times 2 and 4 times 3. For this section, 2 times 1 and 2 times 5. Now they can't be simplified further, so I will convert these mixed numbers into improper fractions. For that, we'll follow the same method. We'll multiply 1 with the denominator and add the numerator over 3 times by 3 times 5, add 1 over 5. The first fraction will change to 5 over 3 times the second fraction will change to 16 over 5. I will then follow the same method like I did on this question here. I'll check, can they be simplified in diagonal? I can see this 5 and this 5 can be simplified. 5 times 1, 5 times 1. We can't do anything to this 3 and 16 because they're not in a common timetable. So I'll go ahead and multiply the numerators and multiply the denominators. And that leaves me with answer being 16 over 3. Let's consider the section on division. I have been given a mixed number and a fraction to divide with. So I'll go ahead and ask the same question. Can the fraction part of mixed number be simplified? In this case, it can't be simplified. I'm going to go ahead and look at the second fraction and ask myself the same question. Can this fraction be simplified? In this case, it can be simplified because they're both in 3 times table. So that is 3 times 3 and this is 3 times 4. Now I'll go ahead and convert this mixed number into an improper fraction. So I'll write down 1 times 12 add 5 over 12 divided by 3 over 4. If you simplify this fraction, it will change to 17 over 12 divided by 3 over 4. At this stage, I noticed that there's a divide sign and I'm dividing two fractions. So I'll remind myself of KFC rule, which is keep, flip, and change. So I will keep the first fraction as it is. I'll flip the second fraction and I'll change the division sign to multiplication. Once I've done this, all I have to do is I'll ask myself the same question again. Can they be simplified in diagonal? In this case, this is 4 times 3, this is 4 times 1. I can't simplify them two because they are not in any common number. I'll go ahead and multiply the numerators and the denominators and I'll end up with answer being 17 over 9. Let us consider another example, but this time we are looking at two mixed numbers. So I'll ask the same question from myself. Can the fraction part of these mixed numbers be simplified? In this case, it can be. This is 5 times 1, this is 5 times 2, this is 2 times 2, and this is 2 times 5. Now I will convert these mixed numbers into improper fraction. I'll do 1 times 2 plus 1 over 2 divided by 1 times 5 add 2 over 5. If you simplify them, you will end up with 3 over 2 divided by 7 over 5. Again, I see I have to divide two fractions. So I'm going to remind myself of KFC. keep, flip, and change. So I'll keep the first fraction as it is. I'll flip the second fraction and I'll change this sign to multiplication. I'll ask myself the same question. Can they be simplified in diagonal? 3 and 7 are not in any common timetable. 2 and 5 are not in any common timetable. So I'll go ahead and multiply the numerators and the denominators, and I will end up with my answer. In this case, it will turn out to be 15 over 14. In this video, we have gone through 4 operations involving mixed numbers and fractions. If you have struggled with the fraction part, watch the video on 4 operations involving fractions. I've included the link in the description so you can access that video from there. I hope you will find this video useful. Don't forget to press the subscribe button, and I'll see you all in the next video. Thank you.